readable, and maintainable VI. Lesson 1. In this lesson, we will cover scalable, readable, and maintainable VIs, several different software development process models, the requirements for the course project, and the task analysis used to derive these requirements. Welcome to LabVIEW Core 3. In this course, you will learn to follow a software development process to design, implement, document, and test key application features in a manner that satisfies requirements for readability, scalability, and maintainability. The course is comprised of the following lessons. To get started, you will need a computer running LabVIEW Professional Development System version 2014 or later, and the LabVIEW Core 3 exercise manual and exercise files, available for download here. Exercises throughout this course will focus on building a boiler controller for a boiler. When you come to an exercise, watch the exercise overview demo, download and open the exercise files, open the exercise manual, and get started. When you have finished each exercise, be sure to return to the lesson and watch the exercise walkthrough, where we'll review the exercise in depth. LabVIEW Core 3 is targeted for the Certified LabVIEW Developer level. Moving on, the Advanced Architectures in LabVIEW and Managing Software Engineering in LabVIEW courses will help prepare you for the Certified LabVIEW Architect exam. Scalable VIs allow you to easily expand the functionality of the VI beyond its original design. An example of this is a single VI that would acquire data from a single wind turbine in a wind farm. In and of itself, it is not incredibly useful and would require multiple copies of the same VI to monitor all of the wind turbines. Creating a VI that accepts an individual wind turbine as an input and reusing it for each of the windmills in the wind farm is a scalable approach. Have you ever inherited code, or worse, written code that looks like this? There's a better way. Aside from the obvious facts of readable code being easier to read, there are several other benefits. Have you ever come back to code that you wrote 6 months ago, only to not have a clue what it does or how it works? Using a clearly defined and well-documented architecture is a good way to avoid this problem. It's also good if you're passing off code to colleagues or coworkers. Using a standardized architecture and common design elements allows your code to be easily understood by people at a glance. Which code would you rather inherit? Maintainable VIs allow you to add new features to the program without completely rewriting it. These are usually well-documented pieces of code that allow other developers to understand how your code works and what it does. One of the benefits of LabVIEW is that it is very easy to start programming and see results quickly, which is great for prototypes and small VIs. However, as with any software development project, planning is essential to success. It is the responsibility of the software developers to follow the process model selected by the lead designer or architect. For this course, you will fill the role of one of the software developers on a team. While there are many software development process models available, in this course we will focus on the Agile model. Agile software development is an iterative approach to developing an application that emphasizes collaboration, working software, and responsiveness to change. Development is broken up into 2 to 4 week increments called sprints. Each sprint focuses on developing a certain set of features. This set of features is called the sprint backlog, and it is created from a list of prioritized user stories called the product backlog. Throughout the 2 to 4 weeks of the sprint, daily meetings are held called scrums. In these, developers discuss what they completed yesterday, what they intend to complete today, and what obstacles they foresee. These meetings should be quick, no more than 15 minutes. At the end of each sprint, the team must produce a potentially shippable product. This is a piece of high-quality, tested code. It does what it should, and it does it well. By delivering a potentially shippable product at regular intervals, you remove the percentage complete metric and replace it with a features completed and features requested metric, which is more realistic and useful. Beta testing is also easy to perform at each release. Regular code delivery also demonstrates to the customer where their money is going. Functional requirements define the operations the software must perform for a successful application. Non-functional requirements define the characteristics of a software implementation and are generally vague and more subjective. Examples of non-functional requirements include implementation date and user interface details. A requirements document is a blueprint for the software application and includes both the functional and non-functional requirements.
You are a member of a Scrum team developing an application to control the startup process of a boiler. After meeting with the customer to discuss their needs and researching the common boiler operations and procedures, the team developed a requirements document. This document will serve as the foundation of the rest of the Scrum development process. Section A describes the fundamental characteristics of a boiler system. Section B describes the non-functional requirements for the application. Recall that non-functional requirements define the characteristics of the software implementation. Section C describes the functional requirements for the boiler controller application. Recall that functional requirements define the functions that the software must perform. This section includes, but is not limited to, definitions of key terminology for the project, a description of the front panel that should be developed, guidelines for the general operation of the boiler controller, a description of the sequence of operations for the boiler controller, and descriptions for the different files that the application will interact with. In this exercise, you will review this document for completeness and accuracy. As you work through the development exercises for this course, refer back to the requirements document for additional information about the functionality that you are developing. Incidentally, if you're interested in pursuing LabVIEW certification, the layout of this requirements document is very similar to the one that you will receive when you take the Certified LabVIEW Developer exam.
Abstraction is a way to describe an application without going into detail on how each of the components will interact with each other. A sub-VI is an example of abstraction. Flowcharts are a good way to plan out the order of execution for a program. This flowchart represents the order of execution for our boiler controller. Ovals represent starting and stopping states, and the rectangles are processes that we will fully define later. Having this high-level overview of the system allows us to easily explain it to others and also gives us insight into possible control errors early on. User stories are another form of abstraction. Throughout this course, we will implement several user stories as different parts of the boiler program. At the beginning of each exercise, we will simulate a sprint planning meeting where we will select a subset of user stories that we are going to implement. Part of your software design process involves communicating with your end users and figuring out how exactly they're going to use your software. One way to do this is through user stories structured in the following manner. As a user role, I would like functionality so that I have this desired outcome. For example, as a boiler operator, I want the user interface to remain responsive while the boiler operations occur, so that I can always shut down the boiler in the event of an emergency. These user stories can be abstracted out and compiled into a list to help decide on which architectures to use and to help maximize code reuse.
After the Scrum team completed the requirements document review, the product owner met with a customer representative to create a list of user stories. Each user story informally describes an aspect of the application from the perspective of the end users and what they need the application to do as part of their jobs. The product owner returns to the Scrum team with a list of user stories. This list of user stories serves as the product backlog for the development of this project. Each development sprint focuses on implementing one or more user stories. In this exercise, you will review this list of user stories to better understand the needs of the end user. Some user stories will be high-level or describe general application behavior. These stories may apply more toward architectural design than individual component or feature design. Other user stories will describe very specific interactions between the end user and the application.
You have completed this lesson. Here's a summary of what we covered.